Good day. For those of you who don't know us, we're the instructional staff for ECE 150, professors Hiran Patel and Werner Dietl, and Douglas Harder. In this topic, we're going to learn about reference variables, that is, an alias to other assignable items. These are called L values, as we'll see. We will see how to use this for a pass-by-reference. This is where a change to a parameter doesn't just change the parameter value, but actually changes the argument that was passed. And we'll see how this can be done. We'll see that this is useful for updating arguments that hold values that we want to change. We will also very briefly describe return by reference. Now, you're probably familiar with the concept of an alias. An alias is just another name for a person or object. Sometimes an alias is written as AKA, short for also known as. For example, Mark Twain is an alias for Samuel Clemens. Charles Dodgson is also known as Carol Lewis, and this individual was also a mathematician. So if you do read Alice in Wonderland, you'll notice there are many mathematical riddles in that story. Now, an alias in a programming language is where one identifier is an alias for another name or another name for a different identifier. Now, aliases in C++ are done through reference variables. So a new identifier of a given type can be declared to be a reference variable if it is prefixed with an ampersand. The reference variable must be initialized with an existing identifier or something else that can be assigned to. So reference variables, like constant variables, must be initialized. Whatever they are initialized with must be assignable. So you cannot assign or initialize a reference variable with an expression such as n+1, and you cannot initialize it with a literal. Basically, whatever it's initialized with must be able to appear on the left-hand side of an assignment operator. Anything that can be assigned to is also known in C++ and in computer engineering in general as an L value. Why an L value? Because it can appear on the left-hand side of an assignment operator. As you may guess, anything that can appear on the right-hand side of an assignment is called an R value. So whenever a reference variable is read, whatever L value it was initialized with is what is actually read. Similarly, whenever a reference variable is assigned to, whatever L value it was initialized with is what is actually assigned to. An alias does not create a new local variable, a new parameter, etc. Instead, it just gives the compiler a different name for an already existing identifier, be it a local variable or a parameter. So here's a sample program that uses a reference variable. Here we have the local variable m of type int that is initialized with the value 42. Next, we have n declared to be a reference to an integer, and it is initialized with the identifier m. So now n is nothing more than an alias for the local variable m. You're probably never going to do this, but we're using this as an example to show how reference variables work. Now, in this line, we print both the value of m and n. However, every single time we print out n, we simply will print out the value of m. So these two values should always be equal. Notice I'm including a tab in there to separate the two objects. Next, I'm going to assign m the value 91. Well, now when I refer to n is just another name for m, and so both m and n should now have the value 91. In this case, I'm assigning to the reference variable, but again, n is just another name for m, so this also will assign to the local variable m the value 360. So if we execute this program, the output is m and n are initially both 42. After m is assigned the value 91, both m and n have the value 91. And when we assign to the reference variable n 360, that updates the value of the local variable m, and when we print them both out, we get, again, both equaling 360. Now, one place where you may actually use local variables is to simplify the appearance of your code. So, for example, here I have declared pi to be a reference variable to a double, and I've initialized it with the constant m underscore pi. The thing is, I'd just like to use a much shorter pi to represent the constant rather than capital M underscore capital P capital I. So it's going to make my code appear a little bit cleaner. It's important to remember that in the CMath library, m underscore pi is actually declared to be constant, meaning you cannot assign to it. Consequently, we must also indicate to the compiler that my new reference variable pi is also a constant. Otherwise, the compiler is going to complain because the compiler does not want to assign to pi because it cannot assign to m underscore capital Pi. But that's more of an aside. The important thing here is by declaring lowercase pi to be a reference variable, it doesn't introduce a new local variable. It's just a different way of accessing the global constant variable capital M underscore capital Pi. Now, up until now, every time we have called a function, the value of the argument is what the parameters are initialized with. Once we are in the function, any changes to the parameter leaves the argument unchanged. So, for example, here we have a function f that takes a parameter k, and what it will do is it will increment that value and then print that value to the screen. So when we call f with the argument 42, k is initialized with the value 42, and that is the value that is incremented. K now becomes 43, so this should print 43 to the screen. Not a problem. Same thing when we call f with the local variable n as an argument. The value of n, that is 42, is what the parameter k is initialized with. The parameter is then incremented and the new value is printed out. So this should also print to the screen the value 43. Here the argument is n plus 107. Well, n has the value 42 plus 107 is 149, and so the parameter k is initialized with the value 149. That value is incremented, and when we print k to the screen, we print 150. However, all of these times, n is left unchanged, so n continues to have the value 42. So if we compile and execute this program, we get the output as expected. 43, 43, 150, and n equals 42. That is, n is unchanged. Now, if we consider a function where a parameter is prefixed by an ampersand, then the parameter now becomes an alias for whatever argument the function was called with. Now, of course, just like reference variables cannot be initialized with anything, it has to be initialized with something that can be assigned to. Similarly, if a parameter is a reference parameter, then any argument must also be an L value. Any change to the parameter changes the value of the argument. For example, here we have a function reset. Reset simply assigns whatever argument was passed the value 0. So again, the reference parameter is assigned the value 0. However, when you call the function with an appropriate L value, what will happen is that L value will be assigned the value 0. So for example, here I have a program where I have a local variable k that is initialized with the value 42. If I now reset k, the local variable k is now what is referenced in the function call. So when we assign n the value 0, k is actually assigned 0. So when we compile and execute this program, we will see the output 0, as that is the value that k now holds. It's important to remember that only objects that can be assigned to can be passed by reference. If I was to call reset with the value k plus 1, we get an error message. Basically, it's telling us that this is an invalid initialization of a reference, as k plus 1 is an R value, not an L value. K plus 1 can appear on the right-hand side of an assignment statement, but it cannot appear on the left-hand side of an assignment statement. Now, something you may have been wondering is, how does CN work? How does it assign a local variable whatever value the user entered as a keyboard? What actually happens here is that the second operand of the right shift operator, when the first operand is a CN object, is actually passed to an appropriate function by reference. So therefore, that appropriate function, once it gets the value that the user entered into the keyboard, then that value will be assigned to that parameter passed by reference, which will then assign that second operand the appropriate value. Now, to actually understand this, we will not be able to do so at this point because we still have to discuss classes and operator overloading. However, this is an example of a operand that is being passed by reference so that it can be changed. Now, here's an application of pass by reference. Suppose we wanted to find both the maximum and the minimum of 3 values. We could just call max and min on 3 values separately, but that's actually excessive work. So instead, what we will do is we will pass the 3 values in as the first argument, and then we will pass by reference 2 values, min and max. Here we will check. If a is less than b, then we will set min to be the value a and max to be the value b. Otherwise, we assign them in the opposite order. Now, whatever the 4th and 5th arguments were when this function is called have to be variables that can be assigned to, so now those 2 variables will be assigned the values a and b in the appropriate order. But we're not done yet, because now we're going to compare C to minimum. If C is less than the minimum value, then we will update min, which will of course update the argument that was passed in the fourth location. And we will also see if C is greater than the current value of max. And again, max now refers to whatever variable was passed in the fifth argument. And of course, if C is greater than max, then we will assign max that value. You will notice that there's significantly less computation being done here than if we were to call both min and max separately on these three arguments. Now, suppose we want to track and print out time. For example, starting at 10:57 and 42 seconds, we might want to track time for the next 10,000 seconds. In order to do this, we'd have to have three local variables, storing the hours, the minutes, and the seconds, and perhaps a little bit more information. Each time we will increment the seconds, but if the seconds ever reach 60, then we have to reset the seconds to 0 and increment the number of minutes that have passed. Each time the minutes reaches 60, we must reset that to 0 and increment the number of hours that have passed. Each time the hours reaches 13, we have to reset that local variable to 1. However, we have to increment the number of periods when we reach 12 because there are 2 periods in one day. Now, here's a program without comments that has 3 such local variables that are initialized with their time 10:57 and 42 seconds, and then we have a counter that counts 10,000 times. Each time we increment the seconds, and if the seconds reaches 60, we reset seconds and increment the minutes. Each time the minutes reaches 60, we increment the hours, again resetting the minutes. And if the hours ever reach 13, we reset the hours back to 1. Then we have a bunch of code that then prints the time to the screen. That's a little bit awkward, and there's a lot of code in there, and there's lots of code doing different things. You may have noticed also that the code that we used for minutes was the same code we used for seconds. Maybe we can exploit this. Suppose we want to write a function that increments a variable that stores minutes or seconds. However, we're going to return true or false based on whether or not the end of a particular minute or hour has occurred. So we're going to pass a local variable by reference that is storing the number of minutes or the number of seconds. And then we'll check. If the local variable that is passed is actually currently assigned 59, then we will just set that local variable that was passed to 0, and we will return true, indicating that a minute or an hour has passed. Otherwise, we will just increment the local variable that was storing either minutes or seconds and return false. Now, suppose we want to write a function that updates a local variable that is storing hours. So if we want to increment the hour, then if the hour currently has the value 12, we will set the local variable that was passed by reference to 1, and we will return false because we haven't entered a new period. A new period starts at noon or at midnight. However, if the hour is not 12, we will just increment the hour by 1, and then we will return true if and only if the new time is 12, meaning that we have crossed from morning to afternoon or from evening to night. Notice that I could have had an if statement here. So if hour equals 12, return true, else return false. But instead here, I'm simply comparing hour and 12. That will either evaluate to true or false, and whatever that evaluates to is going to be what is returned from this function. While we're at it, let's print the time out nicely. Let's take a look at these printouts. Notice that the hour, if it's less than 10, is prefixed by a space. Similarly, if the seconds are less than 10, they are prefixed by a 0. This just keeps everything lined up nicely, and you've probably used applications where the clock seems to jump around because they're not using a fixed size width font, and they may not put the appropriate spaces or zeros in the correct place, which makes the numbers bounce around as the time is printed. This function ensures that numbers are printed appropriately. So we're going to allow the user to pass a string. We're assuming that string is either a space or a 0. We will also allow the user to pass a time. It doesn't matter whether or not it's hours, minutes, or seconds. If the time is less than 10, we will return a string that is composed of whatever string prefix was passed together with the time being converted to a string. That is done by this particular toString function. If the time is greater than or equal to 10, and assuming it's less than 99, since we have no time that is greater than 99, then we will just convert the time to a string. So the toString function is actually in the standard string library that you would use if you were using the string class. And as well, if we add two strings together, the plus operation actually will just concatenate them together and make a string that is larger, that consists of the prefix first, and then in this case, whatever is returned by toString. Let's now use this to count time. So as before, we have three local variables, hours, minutes, and seconds, with their appropriate initial values. However, now this for loop looks a lot cleaner than the previous for loop, where we did all of the necessary work inside the program or inside the main function. Here instead, all of the work is done by functions that have appropriate names. So as we are counting forward in this loop, we will first call increment minutes seconds. The local variable second is passed by reference, so it will be changed. It will either be incremented unless it's actually already equal to 59, in which case it will be reset to 0. If a minute has passed, then true will be returned, and the minute passed local variable will be initialized with true. If a minute has not passed, it will be false. If a minute has passed, then we will increment the minute local variable, which again will change that and update or initialize the local variable hour passed with either true or false, depending on whether or not minute was 59 or not. If the hour has passed, we will increment the hour. With every single iteration of this loop, we will print out toString, the hour, possibly prefixed by a space, the minute, possibly prefixed by a 0, and the second, possibly prefixed by also a 0. Now, if you go back and compare this program to the previous program, here almost reading the code, you can figure out what's supposed to happen, and each of the functions, if each function works, it's not an issue. So it's cleaner to read, it's cleaner to debug. If you find a problem, it's probably a problem in one of the functions, and so this is just a much more convenient way of implementing such a program. Now, there is also something in C++ that is called return by reference, and you can sort of guess already how that would be done, but we're not going to be using that in this course. In general, we're not even going to use reference values that much. For the most part, we will only use pass by reference when necessary or appropriate. We will have an additional tutorial for those of you who care to see how return by reference works and to see how cout works using return by reference. But not every student needs to know this at this time. So don't worry about it if you're not interested. So following this topic, you now know how to create an alias or a reference for an assignable variable. You understand that a parameter can be an alias to the argument, and this process is known as passing by reference. You are aware that numerous applications can use pass by reference that allows more information to be changed, and you are generally aware that there is something called return by reference, but don't worry too much about that for this course. You will not need to know return by reference for the final examination. Here's the references, the colophon, and a disclaimer. Cheers!